Okay, this is part 2 of section 5.4, and now we're going to look at the theorem on reference angles. Why are we learning about reference angles in the first place? Well, because we can use reference angles to find the values of the trigonometric functions. Any trig function of any non-quadrantal, that just means it's not on the x or y axis, angle in standard position, which we keep talking about that, and you know what that is now, has the same value as its reference angle, theta r, with the appropriate sign affixed based on the quadrant in which angle theta r lies. So, let's see what they mean by that. Find the exact value, it says. And I've got this little diagram over here that we can use to help us because it's kind of marked off those key places on the unit circle. So we know we have our 30-degree mark, our 45-degree mark, and our 60-degree. Of course, this is 90, and this is 0. And we also know these in radians, 0 radians, pi over 6 radians, pi over 4 radians, and pi over 3 radians. And then we also, if we can fit this in, know our sine and cosine for each of these. Let's see if we can remember how to do that. Of course, this one's easy. And remember, they're alphabetical, x, y, cosine, sine. So cosine theta, comma, sine theta is what we're looking for here. Okay, for this point, cosine is, x is 1, y is 0, right? For this point here, well, let's get them all set up because there's a pattern that if we learn it, it just makes this so much easier. We said all of the denominators are 2's. That certainly makes it easy. And then going up with the y's, 1, 2, 3, applying the square root, but not on the 1 because square root of 1 is 1, so we've simplified it. Coming down with the x's, 1, 2, 3, and then our square roots. Okay. And of course up here we have pi over 2. And our sine being, our cosine being 0 and our sine being 1. Okay, sine of 210. So we want to know what is our exact value for sine of 210. All right, so we want to find that reference angle. Okay, sine of 210 is not one of these acute angles here. So we're going to try and find the reference angle. Where is 210? 210 goes through 90, through 180, and 30 more, right? So it goes to right here. So there's our angle for 210 degrees. So what's our reference angle? Well, it's 210 minus 180, or 30 degrees, right? This theta r, this little angle right there, that's the reference angle. And it says, any trigonometric function of any non-quadrantal angle theta in standard position has the same value as its reference angle. Isn't that handy? And all we have to do is put the appropriate signs on our x and y, right? So this is a y, sine of theta, let's just remind ourselves, is going to be y, and sine of theta in this case, well, looking over here, we said it's 30 degrees is what theta would be, or theta r. Theta r equals 30 degrees. So what's the sine of 30 degrees? 1/2. What is the sign on the sine in third quadrant? Is it positive or negative, the sign? Well, we can see y coordinates are negative right here. So that's the last part, with the appropriate sign affixed based on the quadrant in which theta r lies. So we needed to say, oh, well, that's why y is negative in the third quadrant, stick a negative on it. That's how we use reference angles to get all these other angles that are outside of our little acute angles here. Okay, in B, what's the sign of negative 315? Again, we may want to sketch this. Negative meaning going clockwise, not quite all the way around, but definitely into quadrant 1. Right? Somewhere like that is our angle theta. 270, an additional 315 degrees. So here's theta r. It's that acute angle that makes its terminal side on the x-axis. How do we know what that is? Well, if we take the entire thing and subtract out the 315, 360 minus 315, it tells us this little bit left is 45 degrees. All right, what is the sine of 45 degrees? The sine of 45 degrees is the square root of 2 over 2. What's the y coordinate? Because sine is y, right? Sine of theta equals y. What's y in the first quadrant? It's positive. So positive square root of 2 over 2. All right, now we're doing radians. The cosine, 5 pi over 4. What quadrant is that in? Okay, here's pi over 2, and this would be, it's, of course, this is 0, pi over 2, did I say pi? 0, pi over 2. This would be pi, but if I wanted to see how many fourths I had, that's 4 pi over 4. This was 5 pi over 4, so we must go a little bit further to get to 5 pi over 4. So I'm in this quadrant. What is my theta r? Theta r, what's left if I take pi? I don't need all of this space down here. If I take pi, or 5 pi over 4, sorry, and subtract off pi, right? That's what's going to give me that little bit left there. This 5 pi over 4, subtract off the pi, and it'll tell me what this is. Okay, so 5 pi over 4 minus 4 pi over 4 is 1 pi over 4. So that's my theta r. And so what is the cosine of pi over 4? Looking at our little diagram up here, our little cheat sheet, cosine is the square root of 2 over 2. Cosine of theta is what? X, right? In this quadrant, what is x? X is negative, so it's negative. Okay, and in D, we have another radians example, but we have a negative, so we're going clockwise. Let's just go ahead and look at it. Negative 11 over 6. That's almost negative 12 over 6. That's almost negative 2. If it was negative 2 pi, we'd go all the way around. So we're almost all the way around, but not quite. So here's our reference angle. And what is it? Well, it's 2 pi minus 11 pi over 6. So in other words, 12 pi over 6 minus 11 pi over 6 equals 1 pi over 6. All right, so I need the cosine of pi over 6. Looking at our little diagram up here, and it's not, I know it's not on the camera, but you guys can see yours. Hopefully you made one. The cosine of pi over 6 is square root of 3 over 2. And what's the sine of that in this first quadrant? Well, that's the positive quadrant anyway, so we know it's going to be positive. Okay, that's the end of part 2.